Right-angled trigonometry, problems in 3 dimensions. So the type of questions we get with 3-dimensional trigonometry are similar to those we were getting with 3-dimensional Pythagoras. We're working in 2 dimensions at any one time, but we'll often have to use several steps. So this question here, a vertical mast is supported at the top by 2 cables reaching from 2 points, point A and B. We've got a vertical mast. The cable reaching from point A is 36 meters long and is at an angle of 48 degrees to the horizontal. Point B is at 24 meters from the base of the mast. Now we have to get pretty good at reading these and drawing the diagrams. And when we're tackling these questions, your first step is always going to be draw a diagram of the whole scenario. Keep it simple. So a mast, don't put a flag at the top. A building, just make it a line, not a rectangle. Don't draw a mountain, just draw a straight line. But get all the important information in. Sometimes it can be difficult to work out what goes where. So for example, these 2 cables, are they going, here's the ground, here's the vertical mast. Are these 2 cables going to point A and point B? Or are these 2 cables going to point A and point B? Or, have we got the mast here and we point A and point B? What we've got to look for is the clues in the question. So, we know it's a vertical mast. The cable reaching from point A is 36 meters long and is at an angle of 48 degrees to the horizontal. Well, that's useful because it says we're touching the horizontal. Chances are we're going from the ground there. And point B is 24 meters from the base of the mast, so that's great. It tells us that point B is on the ground, so we assume point A is as well there. Now, it wouldn't actually matter if we said, well, what if this is A and this is B, or this is A and this is B on either side of the mast? This is more stable, so we'd probably draw this in this situation. Remember, if they'd given you 2 angles, if they'd said that point A was 38 degrees and point B was at 28 degrees, that immediately tells you which one's closest. A bigger angle looking up at it means it's closer in, because this is the same height. A smaller angle looking up at it means it's further out. So if you were not sure which angle to give to which, or which to put further away, if they've given you 2 angles, think, well, same height, small angle looking up because I'm close, big angle looking up because I'm close, smaller angle looking up because you're further away. So there's all these clues all the way through. First step, draw our diagram. A vertical mast, and up to you if you want to sort of represent in 3 dimensions or just go either side. We don't know they're opposite to each other, so we might be best off saying, well, look, that's a right angle there to point A, and that's a right angle there to point B. But if you weren't feeling confident with that, you could definitely draw them just on a straight line. And put in the information that we know. The cable reaching from point A is 36 meters long. And is at an angle of 48 degrees to the horizontal. Now here's where this 3D look might confuse you a bit. So if you'd preferred to do, let's pretend these are opposite each other like this. This is 36, this is 48 degrees. Then that would be fine as well. The cable, point B is 24 meters from the base of the mast, and we've also got this cable heading up there. So there's options for how you draw your diagram, and it's a little bit up to you as how you'd like to visualize it. Now our first question is find the height of the mast to 2 decimal places. So they're being quite nice here. You're going to need the height of the mast in order to find the angle here at B, which is going to be our second question. And instead of just saying, hey, find the angle here at B, they've given you the first question, which is this. If they just gave you this, find the angle to the horizontal of the cable at B, then you'd have to look at this triangle and say, well, I've got this piece of information, I need one more. How can I get one more piece of information? I can use this triangle to find this shared side. But really nicely, they've given us both of them. Now our next step, once we've identified what we're solving for first, is to draw a triangle for that problem. So solving question A, finding the height, I'm just looking at this right-angled triangle and then that's nice and easy. Label our sides. I've got opposite and hypotenuse. Choose your ratio. Sine of the angle is opposite over hypotenuse. Write your ratio. Sine of 48 degrees equals h over 36. 36 times sine 48 degrees is h. So h 36 sine 48. Now, they've said to 2 decimal places. You are going to need to use this number in your next working. If you round only to 2 decimal places and use that number, you will get a wrong answer because you'll get rounding error. Keep more decimal places than the final answer needs. And in fact, I'm going to say keep at least 2 more decimal places than the final answer needs. So write down h equals 26.7532. I want my final answer to 2 decimal places, keep at least 4 decimal places, and then give your rounded answer that they asked for with units. Once we've got h, we can move to solving B, and again, draw the triangle for the problem that you are on. That's this triangle. Oh, I should have labelled A up here, by the way, because I had A. This is point B. I know that's 24 metres. I want to find the angle with the horizontal of the cable, and I know this is 26.7532 metres. You must use the longer, the greater number of decimal places, more accurate answer in your working. Solve that as we would normally. Label our sides. Choose our ratio. Substitute our values. And rearrange and solve. I want inverse tan using your calculator. And we get our answer, and they want that to 2 decimal places. See, we had 48.105, so that will be 48.11 degrees. So, the steps that I need you to follow are draw a diagram looking carefully at the question to make sure you're getting that accurate. Draw a triangle for each problem that you're going to solve. Keep 2 more decimal places at least than your final answer needs, and use those more accurate answers in your subsequent working.